Hello, welcome. We're doing a coding stream tonight. The Final Fantasy stuff is over, and today we're doing a coding stream where I will be doing some recoding, refactoring, reworking of pretty much the main loop of the debugger here. And let me explain what is wrong. Let me pull up one of the logs. Here we go. Actually, no, I'll generate a new log so that we can see what's happening. So I'm going to run the debugger here. Yep, we'll load this guy. I'm just going to step through the application a few times. Let's do this. Let's set a breakpoint and go to the breakpoint. Then we'll undo the breakpoint. I'm just doing a few things to generate some logs so that we can see what's happening here. Okay, cool. And then we'll stop, close the debugger, and now we have a new log. Let's open that up. Cool. So here we've logged the two thread queues. There's a debug thread and a UI thread. And this is logging all the messages that go back and forth between those two threads. So you can see the debug thread is getting these messages and then it returns these messages. I spent some time logging what's inside these messages, but I'm not quite done. So there's parameters in here that are not logged yet because my reflection system is still a bit new. Not worrying about that today though. The stuff that is here is pretty useful to see what's going on. So you can see that we started doing step over, and every time we step over, the debug thread sends back the stacks. We don't get in the log exactly what stacks they were, but we also get some debug info, some event info that says, hey, this is the process, this is the thread, this is the stack frame that you should be looking at that we're stepping through right now. And everything works well most of the time. We send a step over event, we get some stacks back. We send a step over event, but this time we get 2 stacks back. We send another step over event, we get 2 stacks back. And so this is because like these extra stacks that come back, the UI can handle it just fine. It just redraws again immediately. User doesn't even know that something happened. But because of some of the complexity in this code, I'm sending too many stacks back. And this complexity is what I want to fix today. Also, there's some really gross state, like this variable right here, stopped at, is not great. Let me show you how it's used. So every so often I call this send debug event info to the UI. I call this in the debug thread, and it sends the debug info to the UI thread, and it stores this state stopped at. And then the problem is that this state, which holds the last stop location of the program, is also used in all these other places where it's used everywhere. Like here, it's used as the parameter of the function that sets it, right? Like this is not great. We have to know what thread we're debugging, and we want to send info from the last. But what it ends up being is state that sticks around for every state that sticks around. Every time you press the F10 button, it sometimes relies on the previous debug info that sent, sometimes doesn't. And state like that tends to cause bugs. So what I would like to happen is we get rid of this state and we figure out why it is sometimes sending to multiple debug events and multiple stacks per every frame. And then hopefully the cause of this bug is that some of this code is not well structured. And so I'd like to introduce some better structure into this code. So I'm gonna have the stream open over here. So please feel free to ask any questions that you have, and I will answer them. I love asking questions. You ask me anything at any time. And so let's get started here. How am I going to approach this? This is kind of the reason I'm streaming this, is it's kind of it's like a big problem in the sense of there's not like a the single best solution of how to do this, right? There's not like a well-known, there's not a single best practice that everyone in the industry knows about how to solve this, right? It's very subjective. And so I wanted to think through it on stream so that I can record my my thought process, so that you can all see how I approach this sort of thing. And my thought process here is that I need some way to enforce that exactly one stack data is sent to the UI thread, right? Like this is send stack data set debug event info. This code sometimes happens twice. So you know what actually I'm going to do is figure out why it happens twice. Maybe I can, let's see. Now I'm using the Visual Studio debugger to debug my debugger, which is kind of a brain explosion moment, until my debugger is full featured enough to actually be able to handle this on its own. Which will happen eventually. Actually, not too far from now. So let's see here. I'm going to F11 to step in. It sends one stack data. So I'm just going to F10 until I hit this breakpoint multiple times, and then I might have a better idea of why. Oh, there it was. I just hit it 2 times. So what happened there? Did I call a function? I think it's basically on lines where it calls a function. It happens twice. Let's see what happens if I do this. Okay, here's one stack trace. Check for messages. I'm currently in the stepover. Logic. Okay, yeah, I've stepped into a function and now I'm waiting for this, for the instruction pointer to step back out. And in this case I encountered a breakpoint. It's probably the breakpoint that I put. See, the way that source level source level stepping debugging works is kind of bonkers. Like, it's actually way more if you've used a debugger, it makes it look really simple, but it's actually way more complicated than it seems. What it does is it will do a single step. Like, it will step a single line of code. Where is that? Where do I have it step a single line of code? Single step past interrupt. Okay, I have it step a single line of code. Then I get the frame pointer. If I have stepped out of a function, then my step over algorithm is done, right? Like, I'm now have to be in a different line of code. If I stepped into a function, then I have to step back out of the function. Otherwise, I have to make sure that I'm in a different source location than before, right? Like, there's all this logic going into this, actually kind of complicated. So let's see. In order to step back out of this function, I actually create a create step out breakpoint. I create a fake new breakpoint that automatically goes away next time I hit a breakpoint. It's like a self-deleting breakpoint. It's a temporary breakpoint. Yeah, the step out breakpoint is a temporary breakpoint. And then right here where we get on encounter breakpoint, this is where it clears the breakpoint for me. So let's, see, it will remove all the temporary breakpoints, and then on encounter exception. Okay, so what I actually, because it's hitting my fake temporary breakpoint, it does on encounter breakpoint here. So then, and that in turn it's like, oh, I had a breakpoint, I should send stack data. That's what it does. And then my guess is that the next time it sends stack data, it is because, it possibly sends multiple stack data here. Yeah, if it steps into multiple functions, it would. And then the last time it sends it is because I'm done stepping through, like I stepped back out, and then I see that I'm now in a different source location, and so I send debug event info, and then I'm done. I'm done with the algorithm. So yeah, this on encounter breakpoint really is my problem. I'm paranoid that I'm actually sending audio to the stream because I did a whole stream a while ago where I was just muted. Yeah, I'm over there talking. Good. This on encounter breakpoint is kind of overloaded. If I go back to the source here, on encounter breakpoint, it has a few different functions. I hit it. I use it when I hit an actual breakpoint. Okay. Well, actually, let's look what his job is. I find the breakpoint that I hit. Okay. Disable it. Rewind execution one instruction pointer, because the way breakpoints work is it actually writes into the debug process memory. Like it writes a new break instruction at that point. It's like a special interrupt instruction. It writes over memory at that point. There's support for hardware breakpoints, but they have a lot of limitations. This way of doing it is actually a lot more flexible. That's why I'm doing it this way. So it rewinds, it like undoes the breakpoint instruction that it wrote into the process, and then disables the breakpoint so that it can run the actual instruction that was there before. So you have to do that every time you encounter a breakpoint. And also, when it does that, it runs on counter exception. So that's normally fine when you hit an actual breakpoint, because a breakpoint is an exception. But I think in this case, we can kind of do it right. Like in this case, when you're stepping over code, you encounter a breakpoint, but it's not like a real breakpoint that serves as an exception that we should pass on to the user. So call on encounter exception. What does that do? It sends debug info about the exception to the user. So as a quick fix here, I'm going to go ahead and just take that out. Okay, in the case that we hit an actual breakpoint, let's also on encounter exception. Like, we're going to consider breakpoints and exceptions different things now, right? We're not going to assume that every breakpoint is an exception that we want to pass on to the user. Now, over here, when we hit our fake breakpoint, we can bypass it without sending exception data to the user. I think that's probably the most elegant way of, like, I think we're no longer sending multiple stack datas back to the user as a result of this. As a result of stepping through instructions. So that's good, but it still doesn't really make me happy. Because I still have this terrible state that's sticking around. Let's examine how that's used. Let's examine how this state is used. It's set here. Okay. If you save a checkpoint, then the checkpoint wants to know what thread the user was looking at when the checkpoint was saved, so that when you restore the checkpoint, you can look at that same thread again and not like some other random thread. When you're stepping over, you want to know which thread that you are stopped at. Okay, so there's like an idea of a current thread, and this stopped at variable is storing the current debug thread. So that's fine. And then we use that to get a stack frame, etc., etc. Same thing here. Yeah, we're single stepping and we're done single stepping, and so we want to send debug event info for the current thread that we're looking at. What logic is this right here? Same thing, step over. We're done stepping over things and we want to send data about that thread. Fine. If we're stepping out, same thing. If we're stepping into, same thing. What is this? End of the step into logic. Continue running from paused. Okay, we need thread data. Why do we need thread data? So that we can single step past interrupt on that thread. Single step. Why does single step past interrupt need thread data? Actually, is my next question. Oh, because it needs to get the instruction pointer where we might have an interrupt. Is that the only reason? Oh yeah, and it needs to set trap flags and all that stuff. Yeah, okay, that's fair. That's fair. Fair. Step over. Okay, this is where we were. Let's continue. Right, this is where we set it. Okay, so now we're back to the beginning. So actually, most of the situations in which we use this gross state is because there's the idea of a current thread, right? If we are able to offload that idea to a different, to some other structure, the current thread idea, then we're doing a lot better. Okay, then that begs the question of, so here's my problem with that. Here's my problem with that. Let's go back to the debugger. Huh? Hello? Back to the debugger. Do I have anything with multiple threads here? No. Okay, so let's instead, yeah. So in Visual Studio, thank you, Visual Studio. Well, actually, come back, Visual Studio. Okay, in Visual Studio, you have the concept of a current thread and a current frame. Okay, current process, current thread, current frame. In Lux, I've gotten rid of that. So like if I can change the frame by double clicking here, and it brings me to a new point in the source code, and it's like, okay, all of the local variables that you're gonna see are relative to the frame that you just double clicked. Okay, so I've gotten rid of that concept. In Lux, well, there's nothing to see here because I have to, let's go way into and run. Thank you. Okay. Oh, okay. This is a Tower of Hanoi solver that has 130 disks. So this is not a bug, and it's not a buffer overrun. But you can see how there's no such thing as a current frame anymore. I'm showing all the frames in the UI. Okay, when I hover a frame, it shows me where in the source code that frame corresponds to. I don't have to double click in order to get. If I click, it brings me to that part of the source code, but I don't have to double click to make it the current frame. So now, if I want to give it the if I want to take this mstop.dat variable and make it not a thing anymore and replace it with the concept of a current thread. Do I want, I don't have the concept of a current thread in here either. There are 4 threads. These are just threads that the OS made. There are 4 threads in this, but none of them has the concept of a current thread more than my, the debugger has to know that when I press F10 to step over, it means do it in this thread. Oh my god, I have a UI bug here. Nice. Very nice. It needs to know that I mean do it in this thread and not in some other thread. Wow. Very nice. Okay, I'll have to make a note to fix this later. Cool. It gets worse every time I do it. Where was I? Yeah. If I have 10, it has to know that I'm going to do that in this thread and not another thread. So that kind of forces my hand, I think. I have to have the concept of a current thread. I think that my program, that this debugger does really well without the concept of a current stack frame. There's nowhere in the debugger that enforces, hey, this is the current stack frame and all variable. You can look at all variables at the same time, right? There's nothing that enforces this. And if I want to have a current stack thread, then I have to make that decision explicitly. So do I want that? Is there any way I can get around it? Can I say, well, no, implicitly F10. So the only way, let's ignore F10 for a second. Let's say that I control the program by doing a completely different thing than F10, and so F10 is not a problem. Maybe I right-click on a thread, and this is kind of obtuse, and no one would ever want to actually use a program that was this difficult. But let's say I right-clicked on this thread and said step, and then I right-click on a different, here are my 4 threads. Yeah. Yeah. I thought I fixed this bug already. That's weird. If I right-click on this thread and say step, and then I right-click on a different thread and say step, right? I could do that. That could be my way of controlling the threads. And that would allow me to have a stackless, no concept of a current thread. Same thing with processes. I don't support it right now, but at some point I want to be able to debug multiple processes. There'll be tabs here. And so if you have a video game where a client and a server talk to each other and you pause one of them, it automatically pauses both of them. It's hey, stop. I know you're talking over network right now, but just we're debugging now, and it just pauses everything. I'm going to do that eventually in the future. And is there going to be a concept of a current process along with that current thread? Yeah, I think everything is just easier if there is a current process and a current thread. Because then I can just press F10. I don't have to invent another interaction mechanism. And so what I actually need to do is highlight the thread that the debugger considers the current. So there's a UX concern here now, right? I need to show, hey, use this. Wow. Use this. The debugger is going to progress this thread when you press F10. I need to show that. And I need to have the concept of a current thread in here. Okay, so I've decided that. I've just talked through that out loud and decided that. Yeah, and then if I want to change thread, I can just click on a different thread. I can just be like, this thread, now that thread, now this thread, now that thread. Changing threads in Visual Studio is kind of a pain, right? You come up here. I'm not currently stopped, so let's F10. You come up here, and then you pick a different, right? Like, you pick this way. And you can't see more than one thread stack at the same time. In fact, if I run Lux in Lux, maybe we can get a better idea of what... Can I run Lux in Lux? Let's run the tester in Lux. And... oh, goodness. Can I do this? Yeah, let's just... Great, run the tester. It starts printing stuff. Hello? 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 Is it running? There it goes. Why did it take so long? Okay, thank you. Okay, good. We got an assert. Oh, probably there's a path difference between the Visual Studio environment, and so it couldn't run its little test programs that it wants to run. But that's fine as long as there are multiple threads. Where's my other thread? Is there another thread here? I don't have thread names hooked up. Good. Great. Here we go. So stop debugging, check for messages, wait until... Yeah, okay, so... and then the debug, the entry point. Oh, it's destroying the debug. It's done running the debugger here for some reason. Yeah, so you can't... Currently, I'm looking at both stacks for both of my threads, both the debug thread and the UI thread. Can't do that in Visual Studio. I really like this. You can kind of see at a glance. If I had thread names, then you would be able to see like which thread is which. At a much faster glance. Yeah, you can't do this in Visual Studio. I want to be able to keep this, but I just need to show in the UI which thread is the current thread so that when I start stepping, the user knows, and then I can click right here and right here in order to change which thread is currently being stepped. I now have a question. Can the Windows Debugger UI handle that? Let's see. MSDN, what is the continue debug event? Yeah. Let's take a look at the debugger loop. Oh, that's right. Oh, I think this is like a new thing that they support in Windows 10 somehow. Okay. Calling the X version of the function means that you support Unicode. That's fine. I don't care about Unicode right now. There's like a way that you can continue. Oh, here it is. Supported in Windows 10. This flag causes thread ID to replay the existing breaking event after the target continues. By calling suspend thread against a thread ID, a debugger can resume other threads in the process and later return to the breaking. Yeah, okay. Starting in Windows 10. Well. All right, well, I'll just need some way to... I'll worry about that later. Am I even running? I think this is Windows 10. I've totally lost track of Windows versions. My computer. Tell me what version of Windows I'm running. Windows 10, yeah. So I could do that development on this computer, but then I'll have to do it backwards compatible okay, well, so this means that I think without this, I'm not able to change the thread that I'm debugging in the middle of a program. It's crazy that it's like Windows 10 only came out, what, like a few years ago? It took 10 versions of Windows for them to support that. Change the thread that I'm debugging in the middle of the debug operation. That's kind of crazy. Anyway. Okay, so I fully decided that I'm going to support having... So I will not, unlike Visual Studio, I will not have the concept of a current frame. I think that improves things quite a bit. But I will have the concept of a current process and a current thread. So that is what is going to replace this. Let's take a look at... Oh, and so then another big thing I have to decide is... what will the interface be like, right? Like the API... The API that... The API between the... Here, I will debug engine. There are two different interfaces over which I can set this. There are basically like three places in which the concept of current thread can live. Okay, it can live in the UI, it can live in the debug engine, and it can live in the debug thread. I wish I could draw you a picture, but the UI is what's shown to the user. Okay, the debug engine is the UI thread, user interface thread logic. It's like the debugging logic that happens in the user interface thread. It's like debug engine. The UI calls into this. Set executable, start debugging, stop debugging, save checkpoint, all this stuff. The UI calls into it. And then there's some state here like, let's see. What are the current stacks? The UI can always query this. What's the current debug event info? What's the current checkpoint ID? All this stuff, right? And then it handles the communication with the debug thread. So which one of those three is going to have, in which of those three is going to live the concept of what is the current thread? That's what I need to decide. If I have the UI do it, then this will say like, let's see. That's start to, there should be like, wait, shouldn't there be, oh, it's input. I haven't abstracted the input yet. So at some point this will say, right now the input event goes directly into the debug engine. I need to get rid of this, but then inside of it like decides what to do with it. Like if you press F5, that comes into here and then it decides what to do from there. So, but at some point it's going to say something like this, void single step source. Okay. This is probably what this is all you need. This is like the user pressed F10 and wants to single step through source code. Okay. Single step over source. Right? If we do this, then I will need a different parameter. Int process ID and int thread ID. Okay. So the UI keeps track of what it thinks is, in this way of doing things, the UI keeps track of what it thinks is the current thread ID and always passes that in here. Okay, that's one way of doing it. Second way of doing it is that the debug engine keeps track of what is the current, okay? Like somewhere in here, I'm gonna have int process ID and int thread ID. And then you have a function that says void set current thread ID int process ID int thread ID, right? And then implicitly, all of the inputs, all of the step commands use this process and thread ID. That's way number 2 of doing it. Way number 3 is we don't add it here. We don't add it as state in this debug engine class. We add it as state in the debug thread. We add it in this class, int process ID is like the current process ID, current thread ID, and there is a message. Where are my messages? Message. Okay. There's a new message, UI to debugger message. Where is it? UI to debugger message that's like set current thread process. And then these step over, step into, step out implicitly carry all of that. Like, whichever was the previous thread that was set, these operations will run based on that. So which one of those 3 do I want to do? There's this trade-off of like if you store this state in the debug thread, then it's easier to write everything, right? Like the debug thread knows everything that it needs. It's all right there. I kind of want to do it the hard way though. I kind of want to put it in the UI. The advantage being that the user always like I think actually some things are more complicated that way because I have to verify, like if the user switches threads, then the debug thread will have no idea about it until that message comes in, and then I'll have to detect, oh, user actually wants a different thread now. And so all this logic will have to happen to switch threads. If I put it in the debug thread and things are a little bit simpler, I can put all that logic in one. Let's see. No, I guess either way we're gonna have like a change current thread context. Okay, I have decided. So here's what we're gonna do. We're gonna make it so that each step in, over, and out command carries with it the current process and thread that it wants to step in or out of. Right, so here we go. Yep, like this will have to like F5, well F5 doesn't need it because that will continue running all threads, all process. So this step over will need yep, current process and thread, current process thread, current process thread. Step into main, that does not need a current process thread, that implicitly steps into main in all processes. Run does not need a, okay. So these 3 right here will need current process thread. That means that I finally have to remove this input from the debug engine, which should not have been there in the first place. And that, I think, is how I replace this guy, which I think I will no longer need. Let me check myself and see whether that scheme that I just came up with in my head actually does the thing that I want it to do. So let's see here. Save checkpoint. So save checkpoint would send its own thread ID. Yeah, that's actually a lot better because the UI knows what thread it's looking at, the user is looking at. And so it should just send, hey, save checkpoint. And by the way, this is the thread that I care about looking at when I restore that checkpoint. There's no reason that so the save checkpoint message should include like a thread ID. Yeah, like a thread ID parameter in here. Okay, so that would be fine. Step over. Okay, we'll have the thread ID as part of the stepover message. So we wouldn't need it. We wouldn't need it here. Finestackframe. Well, why does finestackframe even need finestackframe? What do you actually use in here? Yeah, okay, you do use the thread ID here. And you use the actual frame, the index of the stack frame. But we can like construct that in place and pass that into this function. Because we'll know the thread ID and we'll know the stack frame. Is that true? We'll pass the thread ID in, so we'll have that. Oh, you know what? All we actually need this for is... Wait, what do we need this for? Oh my god. Is there any oh, here it is. We just need to get the current instruction pointer. Yeah, so we can assume for this, we can just assume the top of the stack. Because we're just trying to get the current instruction pointer of the top of the stack, always. Okay. So we have everything we need here if we do this. Yep, this will be passed in here. So we have everything we need here. Yep, this will be passed in. This will be passed in, passed in, passed in, because it'll be passed into as part of step info, step into and step out. Same thing here. Step into is going to automatically use the top of the stack. Same thing. Continue running from paused needs the thread data in order to single step past the interrupt. Oh, so this one's interesting. This one's interesting. When you continue running from pause, like if the debugger hit a breakpoint and the user presses F5, then it needs to undo that breakpoint like we discussed before. And so it just needs to know what thread it put that breakpoint in. It put the breakpoint at the top of some thread, and so it's using that to look up the. So this is actually a bad design. I wonder whether I'm doing this wrong. Like I should, when you hit that breakpoint, immediately remove it instead of. Let me come back to this one. I need to do some more thinking. Oh, actually, that's the last case. Let me see how single step past interrupt works. Find breakpoint. Disable it. This is like step 1 instruction. Set the trap flag. The trap flag is like the single step flag. It means, hey, take literally step 1 instruction and then give me control back of the program. So that's what's happening here. I'm gonna plug in my laptop here real quick. Oh, that's better. So disable the breakpoint. Single step. Re-enable the breakpoint. If we hit a breakpoint. Where does this get used? Single step past interrupt. So this is during F10. Continue running from paused. This is because we just hit that breakpoint. Okay. Oh, that's it. Okay. So we need to know what thread we hit the breakpoint in, so that when we single step past the breakpoint, we can restore it because we're running now. If you didn't do this, when you hit a breakpoint and you hit F5 again, the program wouldn't go anywhere. You need to disable the breakpoint, step past it, and then continue running the program. Amazingly complicated, right? Like continue running from pause actually does a lot of stuff, because when you single step past that breakpoint, you might actually hit another exception, and then you need to, yeah, if it's the single step, which is what you get when you set the trap flag, then you're good. But you might have to do something you have to handle, like there could have been another breakpoint. Oh yeah, this is like if there's an assert. If you put a breakpoint on an assert, and then you press F5 and you hit that breakpoint, and then you clear the breakpoint, and then you press F5 again, this is what happens. Right? Like there's specific code to handle that case. Debuggers are so complicated. Or you could get an access violation in that very moment. So you have to handle all these cases. I mean, I guess there's no reason that you can't get any other exception, right? In any case, so I have to know what thread we were stopped in. So the question that I'm asking myself is like, can I deal with that breakpoint at the time that I stopped? Can I clear it, put the instruction back? Now that I'm and then like when I continue running from paused, that's when I take the opportunity to restore the breakpoint so that I don't have to know what thread. No, I still have to do all this logic. So it sounds like I need a special case. If I hit a breakpoint, then I store off, hey, this is the breakpoint that I currently stopped at, that I currently hit. And I want it to be enabled again if I progress past this point. All right, so here's what we're gonna do. We're gonna go ahead and implement the current. So this is the only place where having a current thread ID concept doesn't help us, doesn't allow us to replace this guy right here. Because this is actually not the current thread that it needs to know. This is the thread at which it stopped. So it's like a completely different concept that I am going to have to store in the debug thread as state. But I'm going to store it as different state. It's not going to be this stopped at. I'm going to delete this. Okay. So there are basically two things that I need to implement in order to be able to delete this grossness right here. I need to have the concept of a current thread, and then I need to have the concept of that the UI stores and passes to the debug thread every time it wants to do an instruction. Hey, now we're stepping this thread. Hey, now we're stepping that thread. The other thing that I need to implement is the concept of what if I hit a breakpoint, where was that breakpoint? I need to store that, and so that I can do all this logic at a later time. Wow. Debuggers are complicated. Isn't it great? Okay. So let's just get cracking on that, honestly. I think I know enough to start writing code here. And I can do this in waves. So now that I've identified all this complexity that I have to do, there are actually 3 steps here. One is implement UI stores thread state. And passes it to the debug thread, and the debug thread does everything from there. 2 is implement previous breakpoint hit code. And then 3, once I have both of those in, 3 is I can delete this, right? So I'm going to break this work into smaller chunks to try to make things. I'm not going to try and do this all at the same time. I'm just going to break it into smaller chunks. So I'm not going to get rid of this immediately. But, okay, so I will get rid of it eventually. So step 1 is in the processes panel, which is what I call this bad boy over here on the right, you are called the processes panel, because eventually there will be more than one. Right now there's just one, but eventually there'll be more than one. So in this processes panel, I need to indicate current thread, an idea of current thread. Is that going to live here? Oh wow, I actually don't even know where I should store the concept of a current thread. Should I store it in the debugger screen? This is like the debugger screen, and then there's also a debug configuration screen, which is the one that came before. Where do I store this state? The debugger screen, what does it know? It knows all the UI stuff, the executable we're running, all the source files we have open, a future for source files and locations that we're trying to open and access, and a bunch of bus listeners. This seems like it could be a pretty good place to show it. Let's also try, the processes panel. What does it know? It's actually broken up into a few different places. The processes panel knows a bunch of UI stuff, whether it's an overlay, more UI stuff, checkpoint ID. Oh, this is if I'm an overlay, what checkpoint am I overlaying of? And then, yeah. And then each tree knows stack data, accessors for memory and debug events, checkpoint ID if I'm currently showing the tree of a checkpoint, the stack of a checkpoint. Current thread. Where do I store the current process and thread? You know, I feel like this is information that we want to know from a couple different places, right? We want to know, the code text area wants to know what the current process and thread is so that it can display that stack differently, right? Like if I'm over here and let's do this. Let's get a few frames in here so that so we can all see what I'm talking about. Okay. Okay, there are a few, well, not this one. Hold on. Okay. Good. So now we have like a few different frames in this program. We have main, and then we have a few others up here, right? You can see as I hover what frame is being shown on the left. Okay, so if this is if this is my current thread, then you can see it's like, hey, this is the source execution point, and these are execution points that are lower in the thread, lower in the stack. If this is not the current thread, then maybe I want to show all these a different color, right? Like yellow is for the current thread, like a bright yellow for the current thread, and a pale yellow. I already use a pale, or there's not really a pale yellow. There's like a dark yellow, mud yellow. I still have to get a UI artist to come in here and make everything look pretty. But in any case, I could have a bright yellow for the current thread and a different shade of yellow for the non-current thread. And then that is reflected here, right? Like this yellow, this would be yellow, and this would be, you know, less yellow or something like that. I can reflect those colors here so that the current thread looks different. So that if two, like let's say I have a widely parallel algorithm of some kind, and I have multiple threads in one, in one, in one, right, in one procedure, then I can see which procedure, which of these little yellow lines is the current thread. I think I need that. And then I can also reflect that over here. Okay, so this is what I'm going to do. The code needs to know that. The process tree needs to know that. So I need to store that somewhere other than the code and the process tree. I feel like the debugger screen is as good a place as any to store this. It already knows the executable that we're running. Should I make like a completely different thing? Should I make like a if I'm following good design, then I'll have like another object that's like a data store for the current process and thread information. But I don't think I'm that married to good design. I could just throw it in here, right? It's fine. Is there any penalty for throwing it in here? Like, if I throw it in here, then I tie it to this screen. I'm never going to want it when the screen's not up. Pretty sure that's true. I'm always going to want it if the screen is up. Like, I don't see any reason not to just tie it to the screen. I can put it, here's what I'm going to do. I'm going to make a new bus for it. I don't think I've explained what buses are. But it's just a way to get data where the caller and the callee don't know each other. So I can make a new bus, and that can kind of abstract the fact that the data is hiding in here. That's what I'm going to do. Yeah, that's what I'm going to do. It's going to be great. All right, let's get cracking on this. Okay, I need to process this panel bus. I'm going to make like a, what should this be called? Debug state bus. Something like that. Debug state. Yeah, debug state bus. Processes bus. Okay, I'm just going to copy this file. Convenient. Okay. Debug state bus. Yeah. .h. Cool. It's going to be a singleton. Yeah, I probably still need all this stuff. I'm going to delete it just in case I don't end up needing it. Okay. Memory accessor. I don't need this. I don't need you. Process panel overlay. Cool. 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 Debug state bus. We'll delete this one. And we will say get current process. ID. Get current thread ID. And then these both have to return where's my debug data? Excuse me. Okay. So far, so good. Now my screen, wait, no. Debugger screen is going to implement, wow. It implements a lot of buses already. And now it's going to implement one more. Yeah. I see that, like, this is a thing that I think a lot of people would say is bad practice. I think it's fine. I think it's fine. I don't think I'm lowering my quality bar by doing this. Specifically because it keeps the code simple. right? If I made a new object, then, you know, this starts to grow. And then if you make a new object for everything, your code just gets complicated. Your code just starts to get difficult to understand. When things are scattered over a bunch of different places, it starts to get difficult to understand where things live. The relationships between objects start getting more complicated as the objects themselves start getting less complicated. I would rather keep the complexity all in one place where I can understand it all at the same time. Okay, so debug state bus, we're going to do this. Debug state bus Lux namespace. I actually already have. Okay, debug state bus. Very good. So bus panel bus. What did I name this? Didn't I? Oh yeah. Debug state bus. Good, good. What did I do? Oh. I pasted this twice. I'm silly. So far so good, and it's going to give me the error that I expected, cannot instantiate abstract class. So we will copy this stuff, paste it here. We are no longer virtual. We are overrides. And we will give it the concept of current process ID and, oops, current thread ID. Okay. So the UI has now has a concept of current process ID and current thread ID. That was easy, right? No problems. Okay. I need to set that current process and thread ID given the information that gets returned back from the debug thread. So get debug event info. Let's see here. I should put this somewhere else. That looks like a good place for it. There's always like this internal logic about the order of these things, and like there's always an order that makes sense to me. I don't know if other programmers like feel about it, but like the order that you put stuff in, especially with a class like this with a lot of stuff in it, like there's a natural order of things, right? There's a natural order that like feels good. It feels like this stuff should come before, and maybe it's slightly different to other people, but like a bus listener, that should always be last, you know, like all the UI, all the buttons and widgets and stuff, they should come first because they're like the thing that you're showing to the youth. Like, anyway. Okay, let's see here. Current process thread. So I have to decide what these are at some point, and I'll probably have to do that by listening to debug events that come in from the debug engine. Like, when is this set? On new debug event data. I need to listen to this. So I need to listen to the UI updates bus. Am I already? UI updates bus. I am. How about that? See, I knew this would be a good place. So back to the debugger screen. UI update. You know, actually, I'm just going to scroll around until I see what I'm looking for. Show source location, promise fulfill. On new checkpoint data? UI updates bus listener. Oh, because this is in debug engine.h. No, debug engine bus.h. UI updates bus. Oh, I see. So I just need to implement. I'm not currently listening for new debug event data, which is all I need to do. Oh, here it is. Debug event data. Great. On new check. So right next to it, read it on new debug event data. We are going to have to relay out here because what I'm going to do is current process ID equals debug engine invoke result here's what we'll do. Events somewhere around here will be get debug info, and that returns an engine debug event info equals. Probably gonna have name spacing problems with all this because it's all in the engine namespace, so let's just throw all that in there. Engine namespace. It's a long line of code. Yeah, it's probably fine. Okay. So basically what we're doing now is every time a new debug event info comes in, and my first pass at this design is just going to be like, every time a new one comes in, I set it just blindly. Debug event info frame data dot m frame data dot m process ID. Cool. And then we'll do another one for thread ID. And then sweet. What I actually want to do here is invalidate, not layout. To force a layout of the whole UI. Debug UI bus? Wait, why is it the debug UI bus? Should I not be using this? Debug UI bus. I think this is just a poorly named bus. Debug UI bus makes it sound like it's for debug things that don't go out the door, you know, to customers like that. But actually it's like the debugger UI bus, and it's doing some things that maybe shouldn't be doing. This should be like window bus, window invalidate. Invalidation is a function of the window, not of whatever the debug UI is, but I'm not going to attack that problem right now. So we're going to invalidate. Yeah, I'll bet you what happens is that, let's see. What is going to be implementing this bus? I'll bet it's, wouldn't it be the debugger screen? I don't even remember. Okay, well. Oh, a bunch of things do, actually, now that I think about it. No, it's a singleton, so there must only be one. What is implementing you? Oh, that's right. I have a debug application, and then so that it reads invalidate, and then it sends the invalidate to the debugger screen, which okay. So yeah. Anyway, that is a thing that I could improve later, but so it's like a gross thing that doesn't really seriously negatively affect the function of the debugger. So I'm not as worried about it. This current thread business is a different story. Okay. That should compile. Let's see what we got so far. Great. Great. It doesn't link because I need to do this. Kill it in the debugger. But it compiles. So what am I doing now? So we want to show that in the processes panel, which is, we want to show which thread is the current thread. Actually, let me do this. Debugger screen. Scroll down a bit. I'm going to set a breakpoint here so that I can kind of catch what it's doing in real time and make sure it's doing the right thing. Oh. Wow, really? I got some linker errors. Okay, well, that's easy enough. We're going to... Where should I put this stuff? Get current process ID. Return current process ID. Not worrying about const correctness here. Wouldn't really help me if I did. Oh wait, I'm being silly. Cool. So now we actually link. Okay. There we go. Current process 37724. Current thread 28772. Yeah, 28772. Looks correct to me. Everything looks fine. So I'm going to hop on over to the processes panel, which contains a process tree, which, let's see, currently hovered frame. Yeah, this is basically what I want right here. Get frame, bounding box, process tree frame, process tree, currently hovered frame. So I currently have the concept of a frame that I'm hovering over, and it draws this, this bind frame at position. Yeah, it draws a box around the currently hovered frame. I want to do something similar, except... Oh, so basically what I have to do here is process tree paint. I have to do something similar where, like, I figure out, hey, which is my current thread? Which is the widget that corresponds to the current thread, and then stash that off, and so that I can draw something behind it. This shouldn't be too hard. Process tree has a currently hover frame, and now it can also have a process tree frame, process tree. thread current thread. Okay, so now I just have to calculate this current thread. And the process tree will do that by, let's see, it has an update. No, it doesn't. I don't need the update, I need the layout. Process tree layout. Process tree layout. Process tree layout. There's the process tree layout. Process tree layout. Here it is. Okay, so it just lays out okay, so in here, basically, here's what I do. If entry, what does a process tree thread look like? Entry m thread thread ID equals what did I call it? Debug state bus. Debug state bus invoke result. Debug state bus events. Get current event or thread ID. Then current thread equals entry. Boom. Done. Okay. Chat asks, is C++ good for hacking? Define hacking. Define C++. Honestly though, like, what do you mean by hacking? This is probably gonna give me a compile error because I probably missed a namespace or something, but I don't care. Deal with that later. Let's go to paint, process tree paint. Then we do if current m current thread, and then we're just going to do the same thing, but we're going to do a different color. We'll do a nice light yellow color. M current thread. Let's see, red, green, blue. No. Something like that. Yeah, let's try that. All right, give me the compile errors. Where are they? Where are they? Tell me what I did wrong. Oh no. This get frame bounding box only accepts frames, does not accept thread UI widgets. Okay. Boom. Process tree thread. Rather than remember any more state during the layout, this currently extrapolates the frames bounding box using the frames. We're just going to call these widget. So, okay, so I'm actually not entirely sure that this will be correct. There is like a pretty serious design error, like a misdesign in my UI, and that I don't have the concept of a div, right? Like I don't have the concept of a container that you can put things in that's just like an arbitrary sizing object. And so I pay for it by like, not like, I have to lay everything out by hand, and then sometimes the layout goes bad and I get like weird sizing problems. So I'm just gonna punt on this for now. I do have to go solve that problem, and then this code will get cleaned up, but I'm not gonna do that right now because that's not the current problem. I'm focusing on one problem at a time. Get frame bounding box. We're also going to do get thread bounding box. Thread. Cool. Yeah, I can see I'm storing off the height. Here I must be like pre-calculating it somewhere else. Like this is what I mean. There's no such thing as a div. So I'm just gonna fake this for now. I'm gonna need this data later. But I'm just gonna fake it right now. I'll have to come back and fix it later, but I won't do that at this moment. So that I can try and get something up on the screen. Okay, so now I can say get thread bounding box. I should have like, ideally, you know, it looks like I'm gonna need to do this a lot. Have a widget that can size all of the things inside of it. So I'm probably gonna have to make something that does this once. But again, not the current problem. Cannot convert from... What? Oh. You should be thread. Okay, good. The error that I want to fix. Debug state is not a class or namespace. Great, so debug state bus.h. Debug state bus. Are we in Lux namespace here? We're in Lux namespace there. Yeah. So this should all work actually, now that I've included this. Oh, that's right. I forgot to do this. Thread IDs, I'm pretty sure on Windows, are global, which means I don't have to also check for current process. Also, I don't support the concept of a current process right now, which I actually think means that I can do this. Yeah. I'm not going to write code for something I don't support. I only have one process. I can always add that code back in later. So I'm just going to delete this. Make things easier for myself. Delete that. Delete this. And if thread IDs, at least on Windows, I don't know whether this is true in other operating systems, but on Windows, I'm pretty sure thread IDs are global. Like there are like no two threads and the entire system will have the same thread ID, even if they have different process IDs ever. I'm not entirely sure that's true. I'm like 85% sure that's true. But it's not a problem I need to worry about until I support multiple processes. So but the reason I'm pretty sure that's true is that a bunch of Windows functions that let you access threads only require a thread ID and not a process ID. So, and they do like let you get threads in other processes and like cross access threads and all that stuff. Okay, great. Now, something should show up on the screen, but it will be ugly. Oh, right. It will be very, wait, that's not a good sign. Did I not fully recompile? Hello? When the breakpoint shows up like that, okay, it fixed itself, good. That means that it's not it's not like up to date. The binary isn't up to date or something like that. So, oh right, I know what I forgot to do. We have to install new bus listener, and it will be the processes debug state bus. Debug state bus listener. Have to actually listen on this bus. The error that we got was that there was nobody listening on the debug state bus. So we're fixing that now. Great. Now someone's listening. If no one's listening, you can't call the bus. The bus has to listen. Some object has to listen on the bus. That's how buses work. Oh, I forgot to wait. I already killed it. Oh, performing full link. Fine. Hanoi. Good. All right. And hey, look at that. It's like a blue instead of I tried to get yellow and I got blue. I don't know how colors work apparently. Processes panel. Okay, so for one, I need to wait. For one, I need to do okay. Is red and green makes yellow. RGB. Oh. 192. And for two, I want it to be a lot lighter than this. So, well, let's see how that looks. Okay, okay. It's kind of light. I'm going to go lighter, though. Let's split the difference between 192 and 1... We'll go like 230. That's a number, right? Cool, cool. Yeah, that's about right. This is just my intuition for what looks good. So, and it should cover this entire box. And so what I'm going to do is hop over to the processes panel and look in my layout function. And at some point, so when I do the frame, I store the height. Maybe that's all I need to do this time. Yeah. Yeah, it's kind of hacky. I don't like it. But that's what I'll do. Okay. So now I have something showing, and I'm going to go in and make it look proper. Okay. This is definitely a hack. I mean, you can tell because I'm, you know, I need to have some concept of like a thing that has a size process tree item. It's like a container that I put things in that sizes and remembers its size and that sort of thing. It's causing me a lot of problems not to have that, so maybe that will be my next fix. But in the meantime, we'll take that, put it there. Put that here. Good, and now I should be able to do this. This will work perfectly. The first time, no problems. Everything's gonna be great. No errors. Oh wow, I didn't think that would actually work perfectly the first time. Hey, look at that. Okay. So now we have a current thread. I'm going to go ahead and run my test case. Let's see, tester. Yeah. Wow, it takes a long time to load this tester app. Unimplemented code path? What happened? Oh, yeah, right. Oh, this is not good. My memory cache cannot handle this memory range. Okay, well. Yikes. Really? Is this repeatable? This is another thing I can make a note of to myself to, oh no. It didn't repeat. I'm never gonna see that bug again. Okay, anyway. Why did I come? Oh, that's right, because some of these tests create like additional threads, and I want to have some multiple threads in my program here. Okay, so okay, it's telling me this is the current thread. Good. We're in this Lambda right now. Boom, I got another thread. It's not actually running yet. Okay. It's made some progress. So right now I should be able to, what I want to do is make it so that you click here, and that makes it the default thread. Click back here, and that makes that the default thread. And then whichever one you clicked, when you F10, it will progress that thread. Yeah. Man, that... I probably need to continue to do some like UX thinking to figure out what is understandable. Like is the thing that I just described good? You know, like, will it be understandable to users that that's what you have to do? You have to click here and you have to click there. Like, there's no hover over this, so there's no way for users to know that it's a clickable thing. Maybe I need to extend the hover. If you hover over this guy, then it extends this gray hover box to the entire thing, and then that way you know it can be clickable. Like, there are clearly some UX concerns here that I need to work through. But this is good for now. I'm not going to think about that on stream. Okay, so let's do this. It's still initializing symbol query. I'm just going to put in a assert in like the next line and come back here and put an assert, put a breakpoint in this line. And now I'm going to press F5. What do we get? What do we hit first? Wow, why does it take so long? I guess I have some perf issues here I'm going to have to work out. Okay. We hit the same thread, so that was kind of boring. So I'm going to put a breakpoint much further down, and then hopefully I hit that other thread. Oh yeah, because it's still in symbol query initialize. Boom. Yep, and look at that. It switched which thread it's showing it as the default thread. All right. So that works. That works, my friends. Cool. So before I provide a way in the UI to change the default thread, what I get to do now is make it so that it passes that current thread through all the way to the debug thread and says, hey, if I press F5 or F10 or F11, I want you to apply that to this thread that I'm passing in right here. And that means that I need to actually get rid of this input. There, I just did it. I got rid of the input. I'm gonna do more work later on like showing the like in the code view, it should show where the default thread is compared to other threads and stuff like that. But I'm gonna do that later. I'm trying to make progress on this for now. So let's see. I think I don't even need this anymore, or this. Inputs. Is it true that this debug engine object listens for how does it actually get input? Debug engine. Oh, I bet I know what's happening here. Oh, great. It's going to forward absolutely everything here, including mouse moves. Okay, well, actually, this is all I need. Yeah, that's what I was afraid of. So a lot of this happened before. A lot of this code I wrote before I had nice things like e-buses to abstract things like this away. Debugger, what? This is main? It really should be like any object that wants input should listen to the input bus. Or no, because actually, okay. That's a really good. Designing inputs is super complicated. Like how to pass inputs through your program. I feel like that's not a solved problem in computer programming. It's the hardest problems in computer science are concurrency, naming things, and then like a close third is propagating inputs through a user interface. Oh my god. I don't want to think about it. So this is definitely kind of a hack that I've done here. And it's a hack that I now need to undo. So the debugger window has an input callback. Mouse move, so the window calls that input callback. If I'm not debugging, I ignore. Oh, wow. Wait, does this mean? I think I can crash my program. Yep. Wow. Somebody's texting me. Dinner is served, so we're definitely going to wrap this up in a little bit. But okay, so what happened? I just discovered I had a bug. The debug engine is always listening for input, even if it hasn't been started up yet. Like the debug engine is not valid. There's no debug thread. The debug queues are not valid yet. But it listened for that F5 key, and it sent that. It tried to send the message to the debug thread that it should start debugging, and there's a crash. So I'm gonna hop over to GitHub real quick and make a note here. I keep finding things that I need to do, and that's fine because I can just add them into. Give me 1 second. There's like exactly one more thing that can fit in my head now. So if I don't write it down, I will forget. Pressing F5 on the debug configuration screen crashes. And I'm gonna do that there. And then, yeah. And then one more issue. What was the other thing? processes panel sometimes leaves extra controls around when the user opens, closes stack frames. I'm gonna have to get some better repros of this stuff later. Figure out exactly what's going on, but there. Now I'm tracking it, at least. Okay, cool. We'll just go ahead and kill that, because it crashed, and it's never coming back. I need to take this and move it out. Like, there's no reason the debug engine should know about input. That's not a thing. So here's what we're gonna do. Yeah, delete that. Delete that. Shouldn't know about input at all. And for starters, so what I want to do in the long term is abstract inputs from commands, right? Like the input is a F5 key. The command is start debugging. And so there needs to be a layer that's like, the F5 key is bound to start debugging. And that's user configurable. And the user can bind F5 to whatever they want. And we don't have anything like that. And so that's why I have this layer right now. But it is interfering with my new feature design, which means I'm just going to move it somewhere else for the time being. Where was that file that... Was it window? No. Window. Was it main? It was main. So I'm going to hop over to main here. I'm just going to take all that code. This function no longer exists. I'm going to take all this code and dump it right there. Okay. Return true. So all return trues need to become returns, and all return falses need to just be nothings. Return false, return false, return false, and then get rid of this. Return trues become returns, because in the old way of doing it, the return true would go into this block and then it would return, and then it would not run this GUI input. So I need to do like that. I can do debug engine.input. Okay, so what I actually need to do is oh. Yeah. I'm gonna need a call into the debug engine bus. Once we get this set up, then we'll go ahead and end the stream. I feel like I made some good progress here. Debug engine bus. So debug engine bus currently has start debugging, stop debugging, is debugging. Debug engine. Do I ever make any bus calls in this file? I do not. Let's do this. Debug engine bus. Just like this. Yeah, here's my example. Okay. This is, when you use a bus, it's way more verbose. And I don't like that, but the C++ syntax basically forced me into doing it that way. So this guy and this guy will go across pretty basic. Okay. Start debugging. Oh, there's going to be a parameter. And then invoke, yeah, so that should be fine. It's these guys that I need to add support for in the bus. Continue running. And then this is the thing that I'm going to add support for right here in 32T. Thread ID. Okay, continue running. Step over. Step out. Step into. No, continue running, I don't need a thread ID. But step over, step out, step into. Should be source, step over, out, and into. As opposed to assembly, step over, out, and into. Chat says, hey, I see you fixed the resolution. I did. Yes, thank you for pointing that out last stream. I streamed that one, and then I streamed 22, 21, 22 Final Fantasy VII Remake videos at a resolution that was too high for my computer and network connection to handle. And so it started getting skippy. And so I turned it down for that stream because it's a real-time game. But then I've turned it back up again, so hopefully this looks a lot better. Great. So I need to take all this stuff, copy it over here, stop debugging. Get rid of virtual. Oh, and override. Good. Debug engine. These will actually be very simple. Debug engine. Continue running. Is just going to do this. Continue running. And I guess I should assert that I am debugging. And that, well, do I need I guess I need to assert is debugging, and that will check whether, yeah, I think that's all I need to do. It's running and paused, and if it's running, if it's already running, and I press F5, nothing should happen. I'm gonna enforce. Should I enforce that here or at another level? Let's do this. If return there. Okay. I think this is a perfectly fine place to enforce that, and then the debug thread never has to worry about it. Okay, so there. Source step over. I can only do that while it is running. Continue running. If it's not debugging, do this. I need an else here. Yeah, because this was a return. I do need an else here. Okay. Great. And in fact, I never like having a negative here at the beginning. So I always like to switch my... I'm going to move this down and move this up. That way it's like it's a positive in the predicate here. All right. Cool. So if I'm running and the key was pressed and it was an F5 key, if I'm debugging a program, then continue. F5 means continue running. F10 means step over and I need to get the current thread ID. I'm going to get the current thread ID right here. Invoke result. This is going to be a different bus. It is the debug. Oops. Debug state bus. In the Lux namespace, which I think I'm currently in, so I don't, wait, no, I'm not. So the Lux namespace. Better add that. Debug state bus. Okay, great. We're getting there, folks. We're getting there. Debug state, invoke results, get current thread ID, uint32t, current thread ID. I guess this is just a lot of piping things back and forth. So here we go. Good. Good. Current thread ID. That's good. That's good. That's a lot better. Will this compile? It won't link for sure because I haven't filled out all of these. This isn't even correct. But what did I screw up? Step over. It's fine. Step. Oh, it's they're now called source. Source step over. Oh, right. So great, now I just have to implement the remainder. Step over, source step out, step into, step into. We don't need this anymore. Okay. Actually, do I want to say, like, assert that the debugger is paused? Actually, this is what I want to do. If it's not paused, then the buttons do nothing. Yeah. Yeah. It's the UI's layer's responsibility to send the, like, so F11 will either start running your program, or step into a function, right? And it's the UI's responsibility to send a different signal in each case. Here in the debug engine, I'm just going to, if you're doing the wrong thing, forbid you. So. All right, this should compile. So we have the thread ID this far. Oh, right. I have to update the tests now. We have the thread ID this far. We still have to put it in here and then handle it in the debug thread. But first, we are going to update all of the tests. Oh my god. This is going to be a lot of test updating. So maybe I won't do this in this moment. Debug engine, yeah. Is there a way I can do this quickly? Can I do this? Input key F5 down. So every F5 turns into a debug engine bus call that looks like this. debug invoke result. F5 turns into continue running. Right? So maybe I can do like this. Key F5, state down. I'm just gonna search in the whole file. It's gonna be awesome. Watch this. Boom. Yeah. Sublime just let me update all of them at once. What else we got? What else we got? I'm invincible. F10 is gonna be source step over. I'm just gonna use thread ID 0 for now. Even though I know that's incorrect, but I'm not actually using it anywhere. So, no big deal. F10, and then I'll have to come and update all of this again later, but deal with that problem when we get to it. It's like a problem that I know I'm gonna have to deal with and I won't forget. If I have a problem I think I might forget, then I'll do it now. But if it's a problem that I know I'm gonna have to deal with later because my test will fail, then I'm like, let the test catch it. Okay. Ooh. Okay, that didn't even work properly. So let's try that again. F10. Okay. Did that work properly? Yeah. Yeah, I think it did. Okay, source step over and source step. So now I have to pay attention to whether this false is on. Damn it, what was the old input event? No. Oh, I need input.h. Yeah, is shift down. So if shift is down, then F11 means a different thing than if shift is up. If it's up, then it means step into. If it's down, it means step out. So here's what I need to do. Okay. Source step into. Okay. I'll do this for everything where it's false. This bothers me. Didn't I just replace all F10s? Key F10. I thought I did. Oh, because there's a space here. Okay, I'll come back to you later. Okay. Source step into. Good. I guess I'll come back to you now. Source step over. Updating tests. Here we go. Source step over. We're gonna lose these comments. Am I okay with losing these comments? Yeah. They're not that great. Okay. Source step over. Oh my god, I got the syntax wrong for all of these. You don't put the 0 there. That's not how this works. Okay, I can fix that too in just a moment. So is there any more F10? No, but there is F11. So now we have to update all the trues. Source step. So if you shift F11, that's step out. So now we are going to update all the F11 trues. Boom. Source step out. This will take some verification. I'm gonna have to like look at the diff and check each of these to make sure that they are the same from before. Because I could have made an error somewhere in that. So now let's do this. The actual syntax is this. And this. And this. Okay. Did I do it? Did I do it? It's not too many errors. Oh, we missed some F5s. Let's do this again. Oh man, ooh, what happened here? Oh, that's not good. That's not good. What was that? Oh yeah, I screwed things up here. Damn it. Oh, I'll never know what I did either. Oh no. Okay. Yeah. I'll have to fix things here somehow. I'll never know. This looks fine though. Okay. Oh, this is the only one. Great. That should be all of the calls to input. Maybe I can get input out of my tests? Nice. Can I get input out of my tests? Nice. Okay, I'm just going to check this real quick. F5, continue running. F5, continue running. F5, continue running. F10, step over. F10, step over. F5, continue running. F10, step over. F10, step over. F5, continue running. Yeah. F5, continue running. F5, continue running. Continue running. We lost that, but I don't care. Okay, step over, step into, step over. Yep. F5, continue running. Step over, step over. Step over. Continue running. Continue running. Continue running. Step over. Step into. Continue running. Continue running. Step over, step over. Step over. Continue running. Step over, step over. Continue running. Step over, step over. Continue running. Step over. And look how much cleaner this is to read now. Instead of F5 and you're like, oh, what was F5 again? It's imperative. It's it's declarative. It says the test is now going to continue running. It's a lot easier to tell what's going on. Here is a mistake. This is a line of code we should not have deleted. Let's go ahead and put that back. 1788. And it goes right here. What the? Okay. Yeah, that was probably that mistake that I noticed before. Okay. Step over, 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 step into, step out, step into, step out, step into, step out. This must be the step into, step out test. Step over, step over, step over, step over, step over, step over. Continue, 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 continue. Step over, step into, step out. Oh man. I have a lot of tests. Step over, step into, step out. Step out. Step over, step into. Step out. Step over, step into, step out. Step out. Yeah, true. Out. True is out. Oh, this has an incorrect indentation. 2203. 2203. Okay. Other than that, it's correct. F5, continue running. F10, step over, step over, step over. Step over. We did it. Okay. And the last thing I'm going to do before I call this stream is I'm going to run tests. And if tests work, then I'm going to be actually kind of proud of myself that I managed not to screw it up. And then we'll submit this and we'll continue with this problem next stream. So let's see. The moment of truth. Did I screw anything up? Yes. Looks like I did. Breakpoints persist. Let's see what the debug thread thinks is happening. It's blocked, waiting for a message. It's paused. So what? Did you never get the... Oh, okay. My guess is that this is probably going to be a pretty easy one to fix. Probably there's just nothing happening here. It's paused and it's blocked, waiting for a message. That pretty much means that it's... Oops. That the message never came to start, to continue running. Okay. Continue running. We walk through the bus junk. Oh, right. Debugger state. Wow, does this debugger state get out of sync sometimes? I guess it would. Debugger state. So maybe the bug is that debugger paused never gets sent. Yeah, that is a bug. I should fix that bug. Oh, I know what's happening. I know what's happening. The test. So the test, what's the name of this test? Breakpoints persist. Breakpoints persist. It's literally the second test in the test suite. So it runs. It waits until it gets a source code line. And then it says continue running, but the debugger paused message has yet to show up in the UI thread. I'll bet you that's what the problem is. I'll bet you. Oops, I did it again. I played with your heart. Yeah, the debug pause message has yet to appear. And I'll also bet you that if I press F5, it will, like, if I press F10 here, it will block waiting on this wait until, and then I will get my message. Boop, there it is. Okay, so I have a choice. I can either wait for debug paused right here, or I would have to update like every test if I did that. Yeah, I would have to put this right here. I would be like, wait until paused for like every test. Is that worth doing? Because the other thing I can do is just the debug engine always sends continue running. It's like delete this. The debug engine always sends continue running regardless of whether. I have to think about the user experience there. The issue here is whether sometimes you press the button too fast and the UI ignores you. I think I just delete this. Like, this is the cause of that bug that everyone hates where you're pressing buttons too fast and the debugger freaks out, or the debugger doesn't respond because the threads haven't synced fast enough. We don't want this bug. We don't want that. If it like, when could you hit this bug? Like, you know a breakpoint's gonna happen and you press F5 as soon as you see the breakpoint, but the computer is a little bit slow for some reason. It spends like 100 milliseconds working on something. You know, maybe your computer's thrashing right now or something like that. Okay. And it throws this out because it hasn't gotten that paused message yet. And then you're like, damn it, I pressed it at the right time. I pressed it so quickly. I'm so good at pressing buttons quickly. I'm upset. So I think all I really want to know is that the debugger is running. If the debug thread gets a continue running message, and it's, oh, it only ever checks for it if it's paused. All right, then I don't even care. I don't even care. In fact, I bet, yeah, if I get the message, and the debugger is in the wrong state, if it's still initializing, it will throw it out, or it will assert. If it's waiting for initial breakpoints, it will assert. If it's running, it will just eat it, which is what it needs to do. Okay, fine. I don't even care. I don't even care. I think the same for all these, yeah. Yeah. Awesome. Let's build tests. I'm hungry, man. I want these tests to pass. Oh yeah. Right. Cool. 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 Oh no. All right. I'm gonna go get some dinner. So I'm gonna call it. Thanks for watching the stream. I'm gonna do these streams more often. I'm really enjoying working on this debugger. You can join the alpha program for the debugger if you want to help. If you want to check out the debugger and help test it at luxdebugger.com. I keep forgetting which computer to look at. This one. So every Tuesday night, I'm definitely going to be here, and maybe other nights also. And so we're going to pick this up in a subsequent night. I'm going to fix this test case offline because test cases are boring, but essential, important. So write your test cases. And then we'll pick this up later and hopefully get into more of the meaty task of actually threading this through the debug thread and making it all work as intended. So thanks for listening. Thanks for watching. See you next time.